Yeah, sorry, my iPad stuck this morning, so I need to borrow 真传真钱 iPad. Okay, we just finished the midterm and then topic 1, 2, 3. So final exam will focus on the rest 4, 5, 6, 7. Okay. So today is a new chapter, new beginning. It's more relaxed this week, I think. Yeah. Just do some simple countings. You will realize that our topic number is not aligned with the textbook chapter, so you need to find the correct chapter to refer in your textbook. Okay. For the exam, I just finished marking one class only. Not your class. Your class is still ongoing. Uh-huh. Yeah. Is it okay? Looking okay? Yeah. Okay. Product rule and sum rule. So what's product rule? Go smaller again, is it? So suppose that the procedure can be broken down into two tasks. Okay. There are one ways to do okay. Another way to do the first task. To do the second task. Okay. Then they are all together. There. There. Way to do the. Okay. So for example, okay. This suppose there are 4 and 5 pieces in the store. Okay. So the question is how many ways you can make a meal if you are allowed to take one veg and one fish at once. Okay, so you can also, how do you count if you want to? You are allowed to take one veg and one meat at once. So you have a V1 up to V4 for veg, and then M1 up to M5 for veg again. So if you take, you can have 4 different choices of veg, and each veg can pair with different meat. Okay, so this is like a Cartesian product of 2 sets. Okay, so how to count the cardinality of Cartesian product of 2 sets? You just multiply 4 and 7. Okay, is it confusing? No? Okay, yeah. So okay, so you got 4 different dish, veg dish, and then 5 meat dish. So how do you pair up them? So you pair B1, B1 M1, B1 M1, B1 M2, B1 M3, B1 okay, 4 times 5 points. Yeah, so last time I make fun with my colleagues because in Australia the Asian store only have like uh, 8 choices for you every day, so never change. When I come back to like Xiamen here, there's like 50 choices here. So if I can take 3 choices a meal, so it's like the possibility is like 50 times 50 times 50. So it's like 10,000 way to make out a meal. So I think if I stay here for 3 years, I can't finish the combination. Yeah. Okay. Next. And next is the sum rule. Okay, suppose the task first task can be done in one. Okay, suppose there's n1 ways to do the first, to use the first way, and then n2 way to use the second way. Okay, where none of the 2 ways are the same. Okay. Then there are n1 plus n2 ways to the stuff. Okay, so let's try the same setup here. Let's try the same setup here. Hey, Shen can copy or not? How? Yeah, not in here. Oh, okay. Different apps a bit not familiar. Okay, suppose okay, suppose I change the question to How many ways to make up a meal if you are only allowed one pitch at once? Okay. Sorry. Okay. How to make this go down? Okay. So if you are only allowed to take one at once, one dish at once, so meaning you can either take V1, okay, V1, okay, let's see, V1, V2, V3, V4, or M1, M2, M3, M4, M5. So that means altogether you can only take there 4 plus 5, which is equal to 9 ways. Okay, one is you multiply, one is you add. So depend on your situation. Okay, is it straightforward or not? Is it straightforward? If it is not straightforward, you should point out. Quite quiet of today. Very quiet. Okay. Is it straightforward? Okay. Still okay? Okay. Okay. Keep going. So next, the inclusion, exclusion of tool set. Okay, this one we see it before. Maybe we will write in word what it means later. So we recall that when you compute the cardinality of A union B, right? What's the formula? You compute A first, cardinality of A first, and then sum out with B, and then take away the intersection. You take away the repeated stuff. So this is the subtraction rule. So these are like a generalization of counting the cardinality of set. Put into words. So like a task, if a task can be done in either n1 ways or n2 ways, okay, then the number of ways to do task is n1 plus n2 minus the number of ways that are common to the two different ways. Okay, so you take away the common way to do. Okay, next one. Next one is the pigeonhole. Okay, the pigeonhole. Oh, there we go. Okay, this one maybe at best I draw the picture for you. Let's say we have how many holes? Let's see. 1, 2, 1, 2, 3, 4, 5, 6, 7. Let's say we got 7 holes. Okay, and then we have, let's draw this as a pigeon. We have 8 pigeon here. Okay, so the claim is at least 2 pigeons must go into the same hole. Okay, so let's do the worst case. So this pigeon here will go here. Okay, and then second pigeon, third pigeon, fourth pigeon, fifth pigeon, sixth pigeon, seventh pigeon. Then the 8th pigeon must go to either one of these. Okay, so there's at least 1 hole with 2 pigeons. Okay, so if you have, so So if the number of hall is less than the number of pigeon, then at least 2 pigeon must exist in one hall. Okay. So this is the pigeonhole principle. So let me state it here. So if you have a positive integer and k plus 1 or more objects placed into k boxes, then there exists at least one box containing 2 or more of the objects. Okay, this is the pigeonhole principle. Okay, next, easy to understand. So, but you should learn how to apply in the tutorial question. Okay, now this part is more interesting here. So we have the permutation and combinations. Okay, so definition. So what's the permutation? In permutation, we care about orders. Okay, a permutation of a set of distinct elements, distinct objects, is an ordered arrangement these objects. Okay, so let's see an example. Okay, let's use example to understand if you don't know the word. So I will say that 1, 2 is a permutation of 2, 1. Okay, because you swap the first coordinate with the second coordinate of permutation. Okay. Next definition. So I want to define R permutation. Okay, what's R permutation? R is a number. So what's this number representing? So an R permutation is an ordered arrangement. Against order is very important of R elements of a set. Okay. Of a set. Okay. So let's look at an example. So for example, 2 permutation of the set containing 1, 2, and 3 element set. Okay. So what are the elements here? We got 1, 2, 2, 1, 1, 3, 3, 1. What else? 2, 3, 3, 2. Okay. So what's the cardinality of the set? 6. Good. So the cardinality of the set is 6. How do you get 6? Do you know how to get 6? Do you know how to get 6? How? 3 factorial. Yes, 3 factorial. Yeah. Yes, 3 factorial. So what is 3 factorial is in this case here? So it's because you have 3 choices in the first place, and then after you pick one, then you're left with 2 choices. Okay. So 3 times 2. Okay. So this is how you count the cardinality of the permutation. Okay. Yeah. So speaking of 3 factorial, we will jump into here now. So in general, how to count the in general, how to count the cardinality of R permutation of n distinct element. Okay, so let's take some n and R such that 1 greater than R greater than N. Okay. So the claim is there are P and R. So how do I define P and R? P and R is N multiply N minus 1 up to N minus R plus 1. There are this many of R permutation of a set way and distinct element. Okay. So when you see this this kind of formula, right, you can just plug in the number first and then see whether it makes sense or not. Okay. So let's try. Yeah. So I'm now teaching you how to read this thing. So P, for example, in the previous case, we got P32. Okay. So first you put N, then N minus 1. Okay. And then what is N minus R plus 1 in this case? Which is equal to 3 minus 2 plus 1, which is equal to 2. So that means you stop at 2. Okay. So it agrees with the previous definition. So how you, I mean, previous example. So how you going to prove this here? Okay. Actually, use the same method, which is using the product rule. Okay. Okay. So like how many choice you can put? So instead of 2, now here become R places. Okay. And then first place you can put N choices and then N minus 1 choices, N minus 2 choices. And then if you keep going on and calculate, the last one will be N minus R plus 1. Okay, that's how you get this formula here. Is it following? Following? Okay. Yeah. If you don't know, you should really like count one by one and then count minus 1, minus 2, and then go to the last R bit and then see that it's actually N minus R plus 1. Okay, just go and count. And count. No? Okay. 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 Yeah. So this one using product rules. So how is it connecting to the factorial? So corollary. So how to connect to corollary? Okay. Close okay. Then P and R is actually equal to N factorial over N minus R factorial. Okay, where what is N factorial? Just reminding you, N factorial is equal to N times N minus 1 times all the way up to 1. Okay. So is it easy to see from here? Let me see. So P and R is equal to N factorial over N minus R factorial, which is N times N minus R plus 1, N minus R, and then going on up to 1, right? And then N minus R keep going to 1. Okay, so this part here cancel with this part. So you left with okay. So which is the formula? Okay. Okay. So this one is easier presentation instead of writing a long product. Yeah. Okay. I should make a remark here. Make a remark here. So sometimes we will write NPR. Okay. It's the same thing as PNR. PNR is your textbook notation. I heard from the Chinese student that you learn PNR like this. Is it? Is that true? Yeah. No? Some no. Oh, C. Oh, you guys didn't learn P. Okay. Yeah. I mean, it's the same principle. So maybe to standardize, we use this kind of notation. Okay. To standardize, we use this notation, but I realized that you guys use in the exam, so I will take note of that. Okay. To standardize, use this notation. Yeah. Yeah. Okay. So permutation, okay? Okay with the permutation. If you have any question or stupid question, you should ask now, okay? Otherwise, you will get confused, maybe for your whole life. Okay? There's nothing, 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 nothing. There's no trick here. Okay? If you don't understand, you should ask. There's no trick here. Don't be shy. Okay, next. So next, we will talk about combination. In combination, we don't care about order already. Okay, so what's the combination? So R combinations. Okay, just now we define R combination. R combination of elements of a set is an unordered selection of R elements from the set. Okay, so for example, let's use a similar example here. Okay. Maybe okay. So let's do this one. This one. Okay. So let's try what's the two combination of the three element set. Okay, you need to pick two, but I don't care about the order. So you have 1, 2, 2, 3, and 1, 3. Okay. So these are all the two combination of three elements. Okay. So the cardinality of this set is 3. Okay. Notice that you see I changed the notation here, right? This here is a set notation, but previously I used the bracket notation. Remember, the bracket notation is the ordered pairs. Okay. So when I put bracket, that means the order is modern. When I put a set notation, then that means the order is not modern, because the set containing 1, 2 is the same as the set containing 2, 1. So they are equal set. Okay. So that's why this one become a set notation. Okay, so how to count these numbers here? Okay, so how to count the numbers here? How to get the 3? So the number of R combination of a set with n elements, n is in the positive. Repeating this. Yeah, I put like this. So 0 such that n is equals to CNR. So we call it CNR again. It's n factorial over R factorial n. Okay, I think this formula is you have seen it before, right? You've seen it before. N factorial over R factorial times n minus R factorial. Okay. So ever wonder how this formula comes from? Why you need to divide? Ever wonder how this formula comes from? No. Okay. So what is CNR? Okay. So you can use the PNR to understand it, right? So let's use this example then. Okay. So how do you count the 6 here? Okay. How do you pick up the element here? Right? So first you pick two of them. Okay. You pick two of them out and then you commute them. You pick two of them out and then you commute them. You pick two of them out and then you commute them. So then you get the number of all the n. Okay. So similarly, if you want to pick R element from n, okay, so you can first pick them out, okay, and then you commute them. Okay. So you pick the n element out, R element out of the n element, and then you commute the I element. Okay. Commute all the elements. Right. So by theorem, what is PNR? PNR is n factorial over n minus r factorial. Okay, CNR is what we want to find, and then PRR is r factorial over r minus r factorial. What is r minus r factorial? 0 factorial. What is 0 factorial? 1. 0 factorial is 1. So CNR is equal to n factorial over r. Okay? Yeah. So next. Okay. So if you stare at this formula long enough, okay, try and stare long enough. Okay. Try and stare long enough at this formula here. Okay. There's one thing you can observe. You try and stare on it when I write. Okay. So there's some symmetry in this set here. Okay. What's the symmetry here? So actually C and R. Hey, ask him to wake up. I want him to see this. Hey, see this, see this. This one very interesting. Okay, this one very interesting. You must know for your whole life. Okay. Yeah. So CNR is equal to CNN minus R. Okay, this one very interesting. This one very this observation very nice. So what does this mean? So this means, for example, C5 3, okay, for example, is equal to C5 2. Okay. C5 1 is equal to C5 4. Okay. And then C5 0 is equal to C5 5. Okay. So if you arrange this number here, okay, if you arrange this number here, arrange the number here, too big. I cannot reset attention. Change that. Oh, it's not easier than the two blocks. Okay, so if I arrange this number like this, okay, this one, delete. Okay, if you arrange the number like this, you can see that the last one is the same as the last one, the second last is the same as the second last, and then so there's a symmetry with this number here. So if you know half of the number, you can know the other half of the number. Okay. So there's something we call a duality here. Okay. So if you know half of the number, you can know the other half of the number. You don't need to compute twice. Yeah, this is something I use in the research. Okay. So if you stay long enough on this formula here, can you see something? Can you see how is this true? Okay. So proof. Anyone see why is it true? You just swap the denominator. Okay. So the r become the n minus r. And then why is this r? Because n minus bracket n minus r, which is n minus. Okay. Yeah. So you just swap the code. So yeah, the key is the denominator is commutative. Okay. Okay. So what time is it? Okay, still got time. Next. So the definition here. Yeah. So I like this kind of thing a lot because I working with algebra, right? So I like the symmetry. Anything got symmetry, I like. Mm. So it's like the car, right? The car. So if the car, you cut it into half, the left and right is symmetry. Okay. Is it? I mean, not cut. I mean, cut from the front. Okay. Not cut different way. Different way is not like, yeah, it's not symmetry. Okay. Okay, next one is the actually this number here got another appearance, which we call the binomial coefficient. So sometimes we will write C. We also will write n choose R, okay, which is the C and R. It's also known as is also known as binomial coefficient and choose R. Okay, so what's the binomial coefficient? So we have to know about what is binomial expansion. So what's binomial expansion? Let's look at example first. So for example, x plus y squared. Okay, x plus y squared is what? S squared plus xy plus yx plus y squared. Okay, which is equal to x squared plus 2xy plus y squared. Okay, so which is equal to maybe I write this form first. 1 xy plus. Okay, so binomial coefficients means they are the coefficient of these monomial. Okay, this monomial. Okay, and binomial here is because you're expanding two different monomial, the sum of different two monomial, and expand to power n. Okay. So what is 2 here? So the 2 here means you expand. You look at the coefficient of products that contain 2x. Okay, product that contain 2x in power of 2 expansion, and then you For 2, 1, you look at the products that contain 1x in the product expansion. Okay. And then 2, 0, you look at the product that contain no x. Okay. So this is the combinatorial where to see it. Okay. So for example, this number here can help you compute large power. For example, this power here. Okay. So I provide a formula that j equals 0 for, and then for j and j. Okay. So this is okay. Try and see this example first, and then try see this example first. So what this mean is 4, 0 x circle plus 4 x circle. Okay, so this formula provide you a powerful tool that you don't need to do this kind of expansion. Okay, you can imagine, go and expand it. Okay, go and open out the bracket, but you don't need to do that. We got this formula here, and then this binomial coefficient will help you count the coefficient in front of this monomial. And then what's the formula of this formula for this binomial coefficient? We have this theorem that CNR is equal to n factorial over r factorial times n minus r factorial. Okay, so you just plug it into the factorial formula, and then you will see that it is equal to x4 plus 4x cubed plus 6x squared y squared plus 4xy cubed. Okay, so yeah, so try. Okay, first of all, any question on this part or not? So we are claiming that 4, 1 is equal to 1, 4, 1 is equal to 4, 4, 2 is equal to 6, and then the other half, we said that we can figure out from the other number, right? So this one is actually 4 equal to 3, and then this one is equal to 4 equal to 4, 4, 4. Okay, so now use the factorial formula to do it. You want me to show you, or you are okay? You are okay? Huh? You want me to show you, or you can do it? Huh? Show. Okay. Maybe show 1, show for 2. For 2. Show for choose 2. Okay. So for choose 2 is what? N factorial over r factorial times n minus r factorial. Right? Okay. Which is equal to 4 times 3 times 2 over 2 times 2, which is 2, 1, 2, 1, 2, which is equal to 2 times 3 is 6. Okay? Can believe me, so you can go and compute this one. Okay. Okay. The one thing is I want you to generalize this formula to x plus y to the power n. Okay. Try generalize, and then I think in textbook they prove it. After you generalize it, see is it the same as the textbook, and then if you want to see why is it always true, you can go and see the textbook. Okay. Otherwise, you have to know how to use it, how to use this formula. Okay. What time is it? 9:40. Okay. Since close to 9:50, maybe we take a break and then we come back and then see even more easier way to compute this binomial equation. Then we'll come back at 10:59.啊，好用，好用，
我家有小哥，
好用，好用，好用。
没有看到有小哥，会不会那个
只是我不能够拉大，lag 不会，很好，
拉大会拉大什么事？
就拉大
对啊，
就要出去了，然后我就要一直移，我就要这样移，这样不要
拉大是
就这样，
什么事？
就是呀，这样大，因为你看我现在字很大，
嗯哼，
因为我放很小的写，如果我要再小一点，我要再放大一点，如果放大一点，我就要过去，
对呢，因为它那个 resolution，因为那个 resolution，
这样
嗯，
这样会 blur 吗？
我会，
你 blur？你 blur 了啊？
因为
哪一个？
因为太快啊，我
哪一个？
跟不上。
哪一个？你就听先啦，
原来我就听罢了，
呀，你就听嘛，
我就听罢了，
除非有什么来，真的有问题，你就要问了。
嗯，中学是有忘记了，每次学的。
哎，做这个中文又整这个，
什么意思？整这个
就是这个来的吗？
咋整？
就是这个来的，
对啊，
还是4×3和2×1，
对啊，
和2×2咯，
对啊，
做2×2，
好
几度啊
，r 跟 n minus r 吗？
？R 是对，上去看，它上面有写
，OK，
，R 是2，
啊
可是 n 乘，它是这样子是吧？是
啊，
n 括弧 n 减 r，
你讲上面还是下面？
下面
上面是 n 啊，上面是
n 吗
n factorial to r factorial 乘什么来着？
是 R 乘 n minus r，
啊，是减2不是2？
是，你上面有写到是吗？
有啊，我写了，
这个这一样啊，这两个是。
这个 for 这个，这两个一样的，这样
我在研究，我这有一点乱的是，好像又有一点明白。
哪里乱？行，
但这我会等于这个的，
懂意思？
也就是4×2，2×1就等于4等号，
对啊，
2×2这里等于2等号。
2×1啊，
是啊，硬可以不写出来。
对啊，嗯哼，要写到完啊，
在中学是啦，我的老师
是啊，
容易看嘛，那样子。你
可
也懂
以是容易看，
讲的。我中学是用这个的，
我也是，
这就会等于6了。
哪里？
我乘完我就懂了，是其实有个2×3=6哦。
是不是？我不会骗人的，
对，考试很难呢。
很难呢。
对啦，有几题啊，比较
我
难。
觉得不是难，可能你们没有看过，然后你们吓到，就是啊
我尽力了。可是你改了，你就懂我尽力了，真的。
，OK
你每次出题的方法都是怪到我，
啊，是什么？
都是怪到我啊！不要这样讲，他会觉得他自己很变态。哎呀，很无聊啊！你这题目，所以 combination 这3个写法都可以啊。
啊，
combination 这3个写法都可以啊。
对，没错
然后也可以，这个是它的另外一个名字。
，yes。coefficient of the bottom expansion。
对啦，这个我会去研究一下就好。
嗯，啊，OK，推进来，因为那个卡。哎， Yep.
The permutation is the ordered list of a set.
Mm-hmm.
And why is it like the ordered list of 1, 2
Mm-hmm.
is a permutation of ordered list of 2, 1?
Wait, say again.
No, from the example from this 1, 2, why is it like this? The 1, 2 ordered set is a permutation of 2, 1 ordered set. It's not like that. 2, 1, 2, 1.
You said the definition is what?
No, I'm confused with this. The definition of this. Like
Uh,
the permutation of 2, 1 is 1, 2.
so you're saying permutation of set is another set, is it?
Yeah, I'm confusing. Yeah, and this. Like,
So what's your confusion?
oh, I mean, like, what this?
Yeah. So
Uh,
what permutation mean to you?
Permutation. Well, to me, it's like an
Order set?
ordered set. Yeah,
Set with order.
it's a set with an ordered set.
That's correct. I think this is correct. Yeah, let me think. Okay, if I really want to use the definition to write, actually, because this one is actually permutation of an element.
Oh, okay.
So I didn't actually I hide this thing. I didn't tell you what's the permutation of an element. So if you really want to use this definition to see this thing, so I can say that this one. If you want to follow this formula definition, then you need to write this. This one is the permutation of the element. I just hack into the tablet. I didn't tell you.
Oh,
Yes, I want you to just see the
like the switching.
the switching.
Yeah.
Because
Okay.
this one also cannot apply this definition because this is permutation of an element.
Yeah.
Not of a set. Yeah. So if you want to turn this into this kind of permutation of a set, then you can write this.
Okay.
Yeah.
And the brackets are the ordered set.
Yeah.
Okay. Thank you.
Seng. I marked the other class, right? I got the average around 54. 54. I think should be okay, 54. Pass, no? Okay. I mean, yeah. Highest score is like 83. Yeah, highest score is 83. So let me cut this. But I haven't seen 80 above 80 in the class, so I'm not sure yet. So because you and the other class is first year, then the class I mark is second year. So I think, so I think are the question like very okay? What do you think about the question in the exams? Huh? Huh? Oh, don't understand the question. Okay, yeah, because I saw some of you don't answer following the questions. What else? Is it like look new to you, like the questions different from the tutorials or not? Different. Okay. Yeah. Okay. How about in terms of time answering the question? Not enough time. Just enough. Enough time. Enough time. Okay. Some enough, some not enough. Okay. Yeah, because I think sometimes what from my experience and then from what I see or see from your answer, you're like, I mean you are okay. I think you are. I'm guessing. So see if I'm right or not. So you are like shocked with the question, is it? Like never see before and then shocked. Okay, so this kind of feeling, right? You should try first. Okay, instead of shock, you just go and try first. Okay, yeah. Because I think the second year one have seen this kind of question before. Not to say the exact style, but the way of the question. So I think they handle it quite well. Although they cannot like provide the full answer, they will try method. Okay. So when you try method, right, I will give marks one. But if you just straight away right answer, I don't know why some of you without step one, you can straight away find, for example, the Chinese perennial theorems. Suddenly get the final answer. I also don't know how you get it. So if there's no marks, then I cannot give you. Okay. I cannot give you marks, Yeah. Huh? All right, draft paper. Next time you should like put in your draft paper then. Yeah, put in your draft paper. Maybe you don't have enough time to transfer answer, right? So just put in your draft paper. Otherwise, the answer is like got even. Suddenly got that answer. Huh? Oh. Yeah. Yeah. So if run out of time, you got the full answer in the draft paper, just put the draft paper inside your answers booklet. Just tie it up. Make a hole, tie it up. Yeah. Because I give 7 marks for the question. It is impossible the 7 marks is just for a single last answer. Okay.
Chinese remainder in first, but if no step, but I wrote like
Exception.
yeah,
Yeah, that one should be fine because this one's small number. But the big number, how you justify? I don't know how you justify. At least I don't believe you suddenly like okay. Some of you are clever because the range is 50. So you just go and test the number. Test the 50 number and then found that. Oh, that one okay. Because yeah, my question is like fix the range too small. Until you can test the number, try and error. Okay. So step is very important. Yeah. And now, maybe after replacement, I will find times to let you all see the test and then if you found some discrepancy in the marking, then we can discuss and then adjust the mark. Yeah, like quiz, like quiz. Exactly like quiz. Okay. Yeah. Okay. But we can't discuss the question now because some of you haven't taken that. Yeah. Okay. That's regarding the exam part. So I want to remind you, you got the triple pass or double pass rule. So you need to pass your both midterm and quizzes, and then pass your final, meaning 40 and above, and then pass the overall 55 and above. Yeah. Okay. Yeah. Yeah. Okay. Okay, let's come back. Okay. Pascal identity. Okay. Now we will talk about this Pascal identity here. Pascal identity. So maybe I show you how to use it first. Now we suppose this is true. We believe it first. Sometimes you have to believe some things, then you can start proving. If you don't believe it. Yeah. So let's start with 0, 0. What's 0, 0? So nothing, pick nothing. This is by definition 1. Okay. How about 1, 0 and 1, 1? Okay. One element, you pick nothing. So there's only one. One element, pick one thing, there's only one. Okay. Similarly for 0, 2, 0 and 2, 1. 2, 2, sorry. Okay. How about 2, 1? Okay. 2, 1 satisfy this condition here. Okay. Both of them greater than 1, such that n is greater or equal to 1. Then we can use this formula. Okay. Try think this one is 2, this one is 1. Okay. So it is linked to the 1 and k minus 1 and k, which is 0 and 1. So it's actually the sum of the previous two guys. Okay. So which is 1 plus 1 is 2. Okay. And then 3, 1, 3, 0, 3, 1, 3, 2, and 3, 3. So similarly, the n, the both n is 1, but the middle part is dot is n plus 1 become n. Okay, the previous. So the next row has something to do with the previous row, and then k minus 1 and k. Okay. 2 minus 1, k minus 1, k, 1, 0, 1, 1, 2, 1, 2, 2. Okay, can follow? Okay. So what is 3, 1? 3, 1 is 1 plus 2, which is 3. 3, 2 is 1 plus 2, which is 3. Okay, then you can keep going on. Okay, so this is actually called the Pascal triangle. Okay, so you can write out the Pascal triangle really quick. 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, and 15, 6, 1. Okay. So this one is actually already what? Already 6 peak 1, 2, 2. Okay. So you already compute up to the 6th expansion of the binomial expansion. Like, you don't need to use the factorial, just keep writing out the Pascal triangle. And actually, this Pascal triangle, right, is called the Yang-Hui triangle. Is it? This is how you taught in China, right? Yeah. Okay. So, 真传 can go to web page. This one. Okay, let me see the Yang-Hui. Yeah, this one. Okay. So actually, like long times ago, China also got this kind of triangle. Okay. So different civilization has looked at the same thing. What? Bigger. Zoom. This one how to go away? This. Okay, cannot. Like this one, just like this one. Yeah, actually, I just found out this 2 years ago. The Yang-Hui triangle. Because I used to learn the Pascal triangle. Okay. Yeah. Yeah. Okay. If you want to look for this, you can go Wikipedia. Okay. But to prove this, identity is not too difficult. Do you want me to show you or just tell you how to do it? Yeah. You want me to show you or just tell you how to do it? Okay. So you just expand the right hand side, then you will see the left hand side. You want me to show or you want to do yourself? Huh? Show on. Okay, I'll show first then. Right. So let's start from the right hand side. So remember the formula, n factorial over r factorial and n minus r factorial. Okay, let's do it. Let's do it. Let's do it. Let's do it. Okay. So what's your goal? Your goal is, what's your goal? Write out the goal first. We do forward and then backward, forward, backward, forward, backward. I tell you the secret already. So this one is n plus 1 factorial over k factorial and n minus 1 minus k factorial. Okay. So now you want to make a bridge between these two. Okay. So how to make the bridge? So see the denominator first. Okay, you need to make to the same denominator. Here is k. Here got k. Here got k minus 1. Right? So how to make k minus 1 to k? Times k, correct? Very good. Times k. Okay. How about here? M plus 1 minus k. Here got m plus 1 minus k or not? Yes. How about this one? Don't have. So what's the difference between n minus k and n minus n plus 1 minus k? Plus 1, very good. Okay, so how to do it? So we will do it now. So we times k on here. And then here, I times k to the factorial. Okay. Plus 1, how to plus 1? I cannot directly plus 1, right? So I have to plus n minus k plus 1. Then this part will become n minus k plus 1 and n minus k. Okay. In case you're confused, I put another bracket here. So it's actually plus 1. Okay. So what you get is k factorial n factorial plus n minus k plus 1 times n factorial over k factorial and n minus plus 1 minus k. Maybe here. Okay, can you see that these two are the same or not? Anyone see these two are the same? Anyone see these two are the same? Huh? Cannot? Cannot? Okay, cannot. Very good. Cannot. Okay, very good. Cannot see. Okay, I like the details. Huh? So, so this one become n plus 1 n factorial minus k factorial. Can see this expansion or not? Can see this? Can see this expansion? Can or not? Huh? Hello? Can see this expansion? Expand this to this. Can? Wait. Can? Okay, I see more people nodding head already. Quick, quick, quick. Hey, they all see already, Jordan. Can ah? Can or not? No lah. I mean, hey, hey. A minus k plus 1 a, okay. M a minus k a plus a. Huh? Oh, oh, can everyone see it already? Okay. Okay, then you just take the difference of these two. So they cancel out. So you left with m plus 1 and n factorial. Okay, which is n plus 1 factorial. Okay. Yeah, so if you need the details, you should write on it. So. Okay. I don't think in future got lecturer can write this for you. So please scroll up. Okay. Okay. If no question on this part, yeah, just now, who is the guy? Is it Pisco or not Pisco, right? Not William. What is the name of the guy? Huh? Christopher or Bertrand Christopher? Okay, yeah. Oh, you are the Bertrand. Okay. Yeah, Christopher pointed out a very good point here. I define permutation as a set. Okay. Yeah, this is a good logic question. I define permutation of a set. Permutation is a set. Okay. But why I say element is a permutation? Okay. This one actually you need to point out to me. But I'm hiding it into the cupcake when I introduce this concept here. Okay. So the permutation here is actually permutation of a set. Okay. Here permutation is of an element. Okay. If I want to use this language to talk about this idea here, I should say the set of order pair the set of order pairs 1, 2, and 2, 1 is a permutation of the set containing 1, 2. Okay. So actually, when I write this sentence here, right, I haven't defined what is the permutation of an element. I just want to like give you an idea of what's the permutation. Okay. Okay, if you don't understand this part, you should go back and stare at these two sentences and then keep staring it. Stare for 1 week. If you don't understand, you come and find me. Okay. Stare for a week. Okay. Stare for a week why these two are different. Okay. This is just some concept. Yeah. If you see it, then you see it. If not, you need to like digest. Any question or not? If not, then we will start new topic. Okay, start new topic. Okay. Okay, this topic is more interesting. Eh? Topic 5. Relation. Relations, okay? Not relationship, but relation. Chapter 9 in the textbook. Okay, relations. Okay, when we talk about relation, right, we often need to start with two things, okay? Relation between two things. So let A and B be set, or set area. What is a binary relation? So a binary relation from A to B is still a set, is a subset of the Cartesian product of A and B, okay, A cross B. So in another word, a binary relation from A to B is a set R of ordered pairs. So the orders is important. So AB and then BA is different. Okay, AB and BA. So we will write ARB to denote the ordered pairs is in the set R. Okay, so a relation is a set. Remember, a relation is a set. A relation is a set. A relation is a and is not related to B if AB is not in the set. Okay, so relation is a set. Relation is a set. Huh? Okay. So for example, what is a relations? What's a relation? Graph. Graph as a relation. So all the functions. A function as relation. Okay. So why? Because we got a ordered pair x and fx, where x is in some domain and then fx is in another domain. Okay? Because it's an ordered pair. Okay, between set. What are relations? For example, congruences. Yeah, we just finished study last week. The exam just passed. Congruences as relation. Okay, so for example, we will write AB is in the relation if A is congruent to B mod M. Okay, so we can write AB. They are related by mod M. Congruence. 3. Divisibility. Divisibility as relation. Okay. So we can also write AB is in the relation if and if A divide B. Okay. Do I need to go further detail or not? Or you are happy with this AB thing? Do I need to go further detail? So for example, in mod 7, okay, in mod 7, 0 and 7 is in the relation because 0 is congruent to 7 mod 7. Okay. And then how about this one? For example, 2, 4 is in the relation. Okay. And then 2, 5 is not in the relation. Okay. Okay. Any others confused? You should keep at least these 3 examples in mind. Yeah. How is function a relation? To be a relation, you just need it to be a okay. Okay, good. So how to check something is a relation again? It's a binary relation. So first you need to start with 2 sets. Okay. So in function, what are the 2 sets here? The 2 sets here should be the D1 and D2. Right? That right? So we have this condition here. So now we want to verify this condition here. A subset of the Cartesian product of the 2 sets. So is this a subset of the Cartesian product of D1 plus D2? Is this a subset of Cartesian product? So the question is this set a subset of the Cartesian product of D1 and D2? Yes, right. Because any point in here, they are all points in D1 and D2. So it's a subset. Then you are done. Okay. Mm. Mm. Yep. Yep. Even if it is not invertible, because you provide a subset inside the product of the 2 sets. Yeah. Don't really care what function is it. Yeah. Yeah. Mm. Mm. Yeah. Subset is how to say, not really strong or not much property you have. You just need to show that everything in here is in here. That's all. There's no structure there. Can I say like that? Yeah. There's no structure there. Yeah. More structure will be coming from the F, what F you consider. Yeah. Okay. So similarly for 2 and 3, you should figure out what is your A and B. You want to try now or you can do it yourself? You want to try now? Okay, I like the answer. Okay. So congruence, what's your set A and B? So congruence is a bilinear relation from what set to what set? What set to what set? Where I pick the A and B from? They are in the in what set? 0 and 7 live in where? No, integer. We only talk about integer in the lecture, right? So actually congruence as a subset, meaning it is a relation of, it is a subset of Z concept. Okay. Similarly for visibility, Z pro Z. Okay. So everything we studied before just live in the world of integer. the congruence, the divisibility. We only define on integers. We don't define like if you really notice, we didn't define what is 2 divided 4.3. Nothing like this. We don't do this definition. Okay. So everything is lived in integer. Okay. So happy or not now? Happy or not? Huh? Why? Why not happy? Huh? Why? Very hungry. Yeah. 10:30 only. Yeah. Very hungry. Okay. Okay. Next. So, there are one relation we care about. Really care about is a relation on one set. Okay. Relation on the set. Okay. But just now I said that binary relation you need 2 sets, right? But now only 1 set. How? So actually it's actually a relation from A to A. Binary relation from A to itself. Okay. So there are 2 sets here. So it's like the divisibility and the congruence. Okay. So definition. Okay, there are 3 properties we really care about. These 3 properties you should understand it using your way. Okay. So one, relation. When we talk about relation, you need to reflect on yourself first. Okay. So first property is called the reflexive. Reflexive comes from the word reflect. Reflect. Yeah, what's reflect? You know what a reflect is? Yeah, okay. The Chinese word is what's the Chinese word for reflect? For the sake of it. Yes. Yeah, yeah, answer. Okay. Reflect to yourself. Yeah. So reflexive means is everything compared to yourself is in the relation or not. Okay. So you want to ask if A is in your relation for A. For example, the second we take congruence mod 7, okay? Congruence mod 7. Okay. So we want to ask is A congruent to A mod 7? Is A congruent to A mod 7? Yes or no? Yes. So true. So AA is in the relation. Okay. For example, 3, divisibility. Is A divides A? Yes, true. So AA is in the relation. Okay. So one question I can ask, what kind of graph satisfy reflexive property? Okay. What kind of graph satisfy reflexive property? Does this look like a quiz question or what? Huh? Never mind, I revealed her answer now. Okay, what's the graph? What kind of graph satisfy reflexive property? Huh? S equal to Y. Why? Huh? Image and the pre-image is the same. Okay. So you suggest Y equal X, right? Okay. So because we are in function, so maybe we talk about fx equal to X. Okay. Yeah. So when you think about this, don't stress first. go and check what is reflexive property. Okay. So reflexive property says that for OA in AA is in the relation. Okay. So that means AFX, AFA, okay, has to be equal to AA for OA. Right? Because every point wait, AFA is equal to AA for OA. So this implies FA is equal to A, which is FX equal to. Okay. And then simple out. Okay. 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 Next. Okay. After you deal with yourself, you need to deal with the others. You need to deal with another person. Okay. So a relation on the set A is called symmetric. Okay. We come back to symmetry again. Left, right, left, and the right, left. Is if AB is in R, then we require BA to be in R as well. Okay. For every AB in A. Okay. There's another property called anti-symmetric. So what's anti-symmetric? It means so if AB and BA in R, then A must equal to B. Okay. So the only thing AB equals to BA is just AA. Okay, let's look at example. So congruence mod 7 is symmetric. Why? Because why? Yeah, because if A congruent to B mod 7, then B is congruent to A mod 7. You believe? Why? Why? So if 7 divide A minus B, okay, then 7 also divide B minus A, right? Because B minus A is minus A minus B. Okay. Following? Okay. 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 3. Divisibility. Is divisibility symmetric? Huh? Why? 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 It's like question 1 in the exam. You say no, you need to tell me why. Huh? Why? Why? Okay, you cannot tell me like that. You need to give me an counter example. This is how you answer the question in the exam. Give me a counter example. You don't need to tell me the reason. Just give me one example is enough. Yeah, 2 divide 4, but 4 doesn't divide 2. Yes. Okay. So, but if A divide B and B divides A, then you can actually prove that A equals to B. Okay. So that's mean this is no. So hence divisibility is anti-symmetric. Okay. So it's anti-symmetric. Congruence mod 7 symmetry. Okay. Next. Okay, the last property you need to know of this day. So a relation R on the set A is transitive if okay A and B are related and B and C are related. Okay, we can relate all the way from A to C. There and C. Okay. So we can relate all of these. Okay, transitive. So for example, congruence mod 7 is transitive. Okay. So if A congruence to B mod 7 and B congruence to A mod 7, then sorry, C here. C. Then A is congruent to C mod 7. Have we done this? Yeah, this one should be fine, right? Should be good. Okay, good. This one just refresh your memory. Divisibility is also transitive. Alright. So if A divides B, B divides C, then A divides C. I think this one we proved before in the class. Yeah. Okay. So that's why those property I will like can remember, because there's this equivalence. I mean this relation in my mind, the transitive relation and then the symmetric relation in my mind. Okay. So every time you see this operation, right, you should think of these three properties. Does it satisfy or not? So these are the automatic how's that? Automatic question you will ask. Okay. You will want to verify. Okay. So so the next part, equivalence relation. So this relation has an adjective for equivalence. What's the equivalence relation? So an equivalence relation is on set A is a relation on set A which is reflexive. Okay, you and yourself have to be in a relation. Symmetric. If you and the other person in the relation, the other person and you have to be in the relation. And transitive. So you can transit between a person B to the next person. Okay. So if two elements A, B that are related by the equivalence relation are actually called equivalent. Okay, that's why we say that logically equivalent, because the propositions are not equal on the north, not exactly the same. So we call equivalent. Similarly here, so we will write A squiggle B. Okay, so for example, in this, I remind you again in our congruence world, congruence mod 7. So we will write like 0 is equivalent to 7. Or last time we used 0 is equivalent to 7 mod 7, right? Okay, so maybe we'll write like this. Okay, so we won't say equal because 0 and 7 they are not equal, but they're equivalent up to the relation. Okay, in this relation they are equal. In different case they are different. Okay. Okay. So next. So actually this number here, you can see that, for example, 0 is equivalent to 7, actually equivalent to -7, equivalent to 14. Okay. And then these all number form a set. Okay, we will call it the equivalent class. So the set of all elements that are related to an element A of A is called the equivalent class. Equivalent class of A. Okay, so equivalent class is set of all elements that are equivalent to A. Okay, this one is the small a element. Okay. And then we will denote by, in your textbook, you will see the square bracket. Okay. Or we will use A bar. Okay. I prefer A bar. I use A bar. Then A is called the representative of A bar. Okay. Representative of the class. Okay. Element is a representative of a class. Okay, before we end this, I want you to observe one phenomenon here. Okay. So we still keep the example of congruence mod 7. How many equivalent class in congruence mod 7? How many equivalent class is in congruent mod 7? How many? How many? 7. So what are they? They are the 0, 1, 2, 3, 4, 5, 6. Okay. So since I said that the equivalent classes is a set, right? So what is in the equivalent class of 0? There are 0, 7, 14, 21, then -7. How about 1? You got 1, 8, 15, 22, and then 6. Okay? And then you can keep going. Form this form the set here. So it is contained. How about the equivalent class of 7 bar? 0. So actually they are the same equivalent class. So to show this, this is a step inclusion. Okay. Okay. So what you can see here is, if you give me any A in Z, okay, A belongs to one of the equivalence class. Equivalence class. Can you see it? So if you give me a number in Z, okay. If you give me a number in Z, it belongs to one of the equivalent classes. Right? Because if you take any number in Z, you divide by 7, the remainder is always less than 7. This is the division algorithm. In fact, it is stronger. Okay, it is stronger here. It is 1 belongs to 1 and only 1. So there's a unique equivalence classes it belongs to. Okay, every person belongs to one unique equivalent classes. Okay, so in this case, right? In this case, we will say that this equivalent classes partition the set. So you got Z. Okay, imagine this. This is infinite plane. Then can make it landscape or landscape. No. Oh, okay then. Okay, maybe can rotate screen or can rotate screen or cannot. You lock it out. Okay, I know how to do. Okay, okay then. But this one like this one okay. Not see the page. Okay. Where's the page? Okay, use this page. So imagine you got the Z, okay? Then the equivalent classes will partition the set. So partition into 7 set. Partition into 7 set. 1, 2, 3, 4, 5, 6. Or like this one. This one. 1, 2, 3, 4, 5, 6. Okay, correct. Like this. Okay. So the equivalent class you will partition your set. So every integer will live either in 7 of this set. Okay. So in next week we will see why formally all equivalence classes can help you to partition your set. Okay. Any question? Yeah. Explain the topic, but equivalent classes. Equivalent classes is a set. Okay. Equivalence classes is a set, first of all. So you need to ask what are the elements inside them. Okay. So if I say equivalent class of A, that means anything that is equivalent to A is in the set. Okay. So if I say equivalent class of 0, mod incongruence mod 7. So what are the number that are equivalent to 0 mod 7? They are the multiple of 7. Okay. Yeah. So equivalent class, you need to ask equivalent class of n element. Okay. And then you need to ask what are the elements that are equivalent to this element. So all the elements that are equivalent to this element is in the equivalent class. How to find these equivalent classes? How to find equivalent classes? So how to find depend on your relation. Okay, maybe you don't understand how to find the equivalent classes here, right? So one naive way to do is you go and test your Z. Okay. For example, you start with 0, okay, and then you start with 1. Is 1 in the equivalent class of 0 or not? No, right? So 1 have to start a new equivalent class. And then you keep doing, and then you do until 6, and then do until 7. On 7, come back to here again, and then you keep going. Of course, formally, you need to, how to say, formally to show that these are the only equivalent classes is not like not ob not obvious, not directly. Yeah. Uh, uh, yeah. I mean, if you want to formally show that these are the only equivalent classes, right? There's some argument you need to do. But in principle, how you find them? Okay, there are two things here. You want to find them. You want to prove that these are all of these. There are two things here. Okay, to find them, you just test. But you need to show these are all of these. This is the second step. These are all the equivalent classes. Okay, there are two steps here. One, we want to find them. Two, you want to prove that these are all the only equivalent classes. Okay. I didn't tell you how to do the step two. I didn't tell you how to do step one. Question? I need example for what? Or other equivalence relation. Let me think. There are a lot of examples, but whether or not I can think of it now. Or you got textbook? Textbook got example. What kind of equivalence relation? Textbook got other example? For now, I can't think of it. Another equivalence. Does textbook or any other equivalence relation? Or I go on Wikipedia. Huh? Other pen of what? Equivalent class relation. I have the textbook, but 16. Can you just show me here? I go. Oh, we have to find the program for the yeah. Yeah. Oh, okay. This one, this one is different because this one is given a partition show. What I want to do today is like give you a equivalence related from the partition. This one is going backward. Give you a partition, then you give a equivalence related. This one is different direction. My direction is equivalent class, partition your set. Yeah. So if you can give me another equivalence relation, then I can show you how it partitions set. That one already, the set it already get partition, but just need to figure out the equivalence class, equivalence relation. Do you want mm, do you want so all are interested in a new are all interested to see another example of equivalence relation partition set? Yes? Yes or no? Yes? Okay, yes, then we'll do. So let's look at this one here. So let's say we got a set of 4 elements here. Okay. And then relation is what? Relation is a what? Is a subset of A cross A, right? So I just need to give you a subset. Okay. So it's equal to the order takes 1, 1, 1, 3, 2, 2, 2, 4, 3, 1, 3, 3. Okay. So first of all, I want to ask you a question. Do you want to agree this is the equivalent class and then we see the partition, or you want to show this? You want to see how to show this is the equivalence relation? Do you want to show this relation is an equivalence relation, or you want to believe this is the equivalence relation and then show it partition the set? Huh? All in details. Okay, okay. All in details. Okay. So what I gave you is just a relation. So what first step is want to show R is an equivalence relation. Okay. Only equivalence relation will partition the set. So first, you need to check the reflexive property, right? So that means for every A, in A cross A, A comma A is in R. Okay. So what are the elements in A? It is 1, 2, 3, 4. Yes. So you want to ask 1, 1 is in R or not, 2, 2 is in R or not, 3, 3 is in R or not, 4, 4 is in R or not. Okay. Yes. So 1, 1, 2, 2, 3, 3, and 4, 4. Okay. True. So here I will say true because 1, 1, 2, 2, 3, 3, 4, 4 are enough. Okay. The next one is symmetry property. Symmetry property. So for every A, B in A, if AB is in A, then BA is in A. Sorry, in the relation. Okay. So look at the relation here. 1, 3 is in A. That means 3, 1 has to be in A. Is 3, 1 in A? Yes. So if 2, 4 is in A and R, is 4, 2 in R? Yes, here. Okay. So of course, you don't need to check when A equals to B, because A equals to B is the reflexive. Okay. So it is satisfied. And since 1, 3 is in 1, okay, since 1, 3, okay, I just write like this. Since 1, 3, 3, 1, 2, 4, 4, 3, 4, 2, in R, it is symmetric. Okay. So transitive, how about transitive? Transitive. ABC. So if AB in there, do you want me to write out or you can think transitive probably? So if AB in R and BC is in R, then AC is in R. For this one a bit tedious or this one because got a lot of so you see, so AB for example, this one a bit tedious because got like how many choices you need to make. You learn counting already, right? So how many choices you need to make? 1, 2, 3, 4, 5, 6, 7, 8. 8 choose 2 is what? Use the Pascal triangle. H choose 2 is what? H choose 2 is what? Huh? Wait. H choose 2 is what?
8 choose 2. What is 8 choose 2? Okay, let's use the Pascal triangle. 28. Oh, 28 combination you need to argue. So you need to argue like 1 1 composed with 1 3. Okay, at most 28. So 1 1 with 1 3 is 1 3 inside there. Yes, 1 3 is inside here. 1 1, okay, got nothing. So 28, I mean at most, because some of them cannot compose. So for example, like 1 3 and 3 1 is in there. That means 1 1 is in there. So 1 1 is in there. Yeah, in there. 2 2 and 2 4 in there. Is 2 4 in there? Yeah, 2 4 in there. Like that. So you need to check all the combination. Okay. Okay. So this is, I think you believe, believe, or go and check. Don't believe, go and check. Okay. So this is the equivalent relation. So how it forms? What are the equivalent class now? Okay. So what are the equivalent class? So let's see what's the equivalent class of 1 bar. Okay. So what is equivalent to 1? 1 is equivalent to 1. Okay. 1 is in there. 1 is equivalent to 3. So 3 is in there. 3 is equivalent to 1. Okay, 1 already put there. And then 3 is equal to 3. Okay, then that's all. So the equivalent class of 1 3 is 1 is 3. Okay, how about 2? 2 is equivalent to itself. Okay. And then 2 is equivalent to 4. So 4 is in here. And then 4 is equivalent to 4. And 4 is equivalent to 2. So close up. It's like this. So what's the equivalent class of 3? Is same as equivalent class of 1. And then 4. So there are two equivalent class of two equivalent classes of A. So A is 1, A is 1, 2, 3, 4, right? So it partitions the set into half like this. Okay. Yeah. But in next week we will see why exactly like that for different equivalent class. Okay. Very detailed or not? Detailed or not? Can I? Okay. Yeah. Mm. Mm. Okay. Yeah, I remember. I recall my first time learn this proving mathematics also. But the lecturer won't show you one. He won't show you, like, because there's a lot of things you need to cover. So I also like I never see this kind of proof, right? So I also don't know how to prove. And then I only like keep learning until keep doing exercise until I know how to write this thing. So I think I know your feeling. So if you don't ask, then I won't do. If you ask, then I will do. Like this thing, right? Once you see it, you learn it, you see it, then you will think that it's actually tedious, right? For example, I have to check this transitive. I need to check all the pairs. The idea is there, but when you do it, you really need to like go and do it. Yeah. So it's not good to do in the public. Okay. 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 Any more question? Any more question? Any more other question? Okay. So the idea that today I just want you to observe that equivalence relation partition yourself. Partition yourself. Okay. Any question? No. Question from here or no? Okay, then we will have a break until 10:19 and then come back for factorial。
你懂忘记反过来的句吧？
忘记翻过来很久了吗？我知道啊，怎么呢？
代表好的嘞。
因为它是长的，所以如果横的话，我会把这个横。
对。
嗯，
哦。
就问你这个不能的咩？你应该能的。嗯，什么都没听懂。OK，有困，
又困又听懂，
重点是困哎，
重点是二。
所以要先搞足先。
relationship 是什么？
什么 relationship？而 relationship 就是一个 subset，一个 subset。
这是什么？什么意思啊？什么？你刚才讲那个，这有3个这个，
我帮你 delete 掉了，
如果 delete 掉
给你重写啊。
，delete 掉你们就没有。
你重写。
我有。
这3个是满足这3个，满足这个或这个，或者是这个是函数的，它就是这2个有关系。
你现在在干嘛？你现在要
我不什么都没。
没一步一步来，一步一步来，一步一步来，一步一步来，一步一步来，一步一步来，一步一步来，一步一步来，
从哪来？
随便你啊，一步一步来，从最原始
你从一开始
呀，一步一步来。一步一步来
什，么叫二元关系？不结合。
二元没有，你现在读的方法就错了哦。人家就要告诉你什么是二元关系，你又问人家什么是二元关系，对不对？所以你应该要看一下什么是二元关系，对不对？所以他说，binary relation is a subset of A cross B， 所以它是一个 set， 它是一个 subset of A cross B，OK 吗？OK， 所以它是一个 set 哦，所以你现在就要去看例子，为什么它是一个 subset 哦？OK， 你看像我们刚才给的这个例子嘛，你看这个 R 这个 relation 是一个 binary relation， 因为它是一个 subset of A cross A， 是 subset 吗？每一个这里的东西都在这里。
是不是还有一二？
有，
减少
呀，这边里面其实有16个 A cross A 的卡丁 ID 是446嘛，对不对？
有1、2、3、
呀，
这边就是1、2、3、4。好，这个等于
所以它就整个东西哦，它也是 partition， 但是还是
它就
整个
这个
呀，这一大 partition。
那个函数的呢？
函数是干嘛？函数是不是给了你一个 subset？
不是，首先就刚才这个，这个集合啊，它有这个集合，那什么就 A 与 B 有关系啊？是 A 和 B 组成结合啊？那什么意思？
就是它是一个 subset 嘛，它 subset 它就是一个 set 哦，对不对？所以就集合，叫它R 吧，加一个名字，取一个名，然后呢？
然后你刚才讲这个双向是什么东西？这样子，这个地方，这几行里面是。
就是我这个 relation 是说什么是这个？这个就是当 A divide B， 只要当 A divide B， 我就可以写这个。
这个是为什么？
就我定的，是我定的，没有为什么，是我定的这个 definition， 这是定义，我定的。
那不整除不也能写这个？
我不可以咯，我要整除才可以写咯，这是我定的，这不是为什么，这是我定的。所以你要分别什么是我定的，什么是 推导出来，所以这个是我的定义。
定义啊
对，这是我定义，这是我 relation 的定义。我有不同的 relation 的定义，不是，不同的 relation 的例子，然后这个例子是我定的，
啊，
所以我会放 ISF 啊 instead of F。
对，这个不是
不是推导出来的，是我定义的，例子是我定义的。嗯，然后你要查的是到底为什么我的定义是一个 binary relation。
那它这两个是 binary relation，它有条件吗？
有条件 binary relation 就是你要 show that 它是两个 set 的 Cartesian product 的 subset， 它是一个 subset of A cross B。OK， 不然你解释给我听什么是 binary relation。
就是 A 和 B 的叫那个叉 A 叉 B 的直接。
的子集 OK， 所以你要 show that 这个东西是一个 A 叉 B 的 subset， 所以 A 是什么 B 是什么，第一个例子。
那这个 A B 是什么？
我问你啊，你知不知道
不知道。
A 和 B 应该活在什么世界里？当我做除的时候，
Z。
对，所以是 Z 乘 Z， 所以这个 relation 应该是 Z 乘 Z 的 subset。所以我问你，如果一个数除另外一个数的话，那我把这两个数拿出来，那这两个数，比如给你想一个号码，比如说2除4啊，对不对？2除不除4？我先问你。
2除4。
OK， 2除4了，我就可以写成这样了，对不对？对吧？所以我现在问你，这个东西是不是一个 element 在这里？
是啊。
所以每一个我都这样子做，这样的话，它是不是是不是一个 subset of？
是啊。
是哦，这样就 OK 哦。
OK。
所以这个是一个 relation 的例子。
这些是例子。
OK。
那函数这个是什么？
函数也是啊，函数也是道理一样啊。所以函数的这一题的 A 和 B 是谁
？Z
不是。
第一、第二。
对，第一乘第二。所以现在要问的问题是我给了你这个 relation 过后，这个 relation 是不是一个 subset 这边？意思说这里面所有的东西是不是都是一个 element 在这里？为什么？
因为这个属于第一。
对，就是这样。所以这个函数是一个 relation。你自己推出来了，你自己不相信。
relation 有点晕。
没有晕啊，只是你不能接受吧？你要接受它，你要接受它。你刚才把所有的那个都讲出来啊，为什么还晕？你只要确保这个
这个是，那这个二表示这两个的二元那是什么
关系？
二元关系。
这整个东西我们都称为R 的一个，R 就是这个 set。OK 吗？
然后它称作 S 是因为它是这两个的之间。
它称作 A 的，它称作 R 的原因是我们要它是 R， 是我们要的。
那这个称作这两个的那个关系嘛？
这两个什么关系
？relation。
再讲一次。
就是这个那是这两个之间的关系。
是这两个之间的关系。是这两个之间的关系。是这个两个之间的关系。是这两个
有关系，
算是 OK， 我知道了。因为在我觉得可能你在想 relation 的时候是说怎样连接这两个东西，对不对？所以 OK， 你可以先保持你这个定义，但是书里面的定义是说这个 relation 是说只要那等下这个讲一下，这个讲一下。我知道你讲什么，再给我讲一下。对呀，OK， 你再讲一次你讲的东西。所以 relation 是说他们两个之间的关系啊，对不对？对不对？
有关。
他们有关系过，他们是不是绑定了？ ，OK，
有关系。
所以它绑定过后，它是活在一个 set 里面的，活
嗯，
在一个 subset 里面的，所以我们用这个来定义它。他们绑定过后，他们就活在这个 set 里面了，可以吗？
行，
可以吧？所以我们
对，
因为如果你说这两个之间的关系，这个东西很抽象，
对，
对不对？但是问题是你有了这个关系过后，这两个人就绑定了，那他就活在一个 A cross B 的世界里，
老师的例子怪怪。
是怪怪呗？
那后面那个
一直很怪。
后面那
会啦
个怎么找不到那个？
绑定了活在一个世界。
不对呗？你跟他结婚了，不是要住在一个？
那你知道
人家就分居了哦，这样话，
我可以有4个老婆？
你看这是 transitive 哦。
OK，
那那个全世界是
4个老婆。好，讲个刚才
transitive 就是说 A 和 B 有关系，B 和 C 有关系，
A 跟 C
就代表 A 和 C 有关系，可以吗？
好像是这
所以
样。
这个是传递性的意思。
对，就是transit yeah， 哇，这么恶心 yeah， transit yeah，
那这
这个音译要看一下啊，
这怎么理解呢？
怎么理解哈？人的关系应该不可以这样理解吧？
啊，人在干。
可以啊，
怎么可以这样很乱的？这样太乱了。
不可以。
哎，
你弟弟跟你妈妈有关系
啊，比如说你跟他是朋友，
关系，
他跟他是朋友，你跟他是不是朋友？
不是。
不是。
如果不是就不 transitive 哦，如果是的话，你们就 transitive 了。可以啊，
我们先假装是，然后我们就看谁这个。
你就讲
如果不是，我们就不是了。
不 transitive 哦这个关系，可以吗？
看人家用人。
举这个例子，这不是之前那个？
对呀，所以
这个是什么？
他定了
那和这个有什
关
么关
系，然后他能
因为我刚才之前证明告诉你 divisibility 是一个关系嘛，所以这个 A 跟 B 有一个关系，B 和 C 有一个关系。那我问你 ，A 和 C 有这个关系，有这一层关系吗？对不对？
嗯，
有关系的意思是什么？就是 A 除 C 啊。
有关系，不是要这样才有关系，
怎样有关系？
有几种有关系？
不是这样才有关系。
有几种？
对呀，有几种关系，这个是一种例子，这个是例子，要分辨例子和那个
所以你说的有关系是有很多种关系，但是那
对
关系是可以自己定义的。
对
嗯，
对。
然后你这样的定义，如果这个整除这个就是有关系的。
对，一次只看一种关系吧。
哦，
呀，
是，
不然关系太乱就不好。
全 CT 可以叫等于是他们名字是吗？
名字？
就是
什么叫名字？
transitive 应该是名词吧？
全 CT 就是一种连接形容词。
对。
形容词。
把它写成是性质。
性质对 property 对。
那学的
然后
括号的
后面那个括号在哪？
括号的意义，现在到底学的是
哪里括号的意思？
就是因为之前有括号，就是两个数 A 和 B，它可以表示一个点，然后也可以就怎么分是
什么意思？
怎么区分它到底是想表示关系，还是说还是其他？就比如说这个
是什么呀？
所谓是括号一个括号，然后这两个数中间隔一个逗号，它也可以表示一个点。
你说这一个还是什么？这样子？
对，这样就怎么区分它到底
要区分什么？
它就这个东西的意义到底是区分它到底在
就他们两个有关系哦，但是他没有告诉你为什么他跟他有关系，他只告诉你他们两个有关系。这个题目是这样，他告诉你谁和谁有关系，但是他没有告诉你怎样从一去一，怎样从一去三，怎么从二去二这样。
这个不是有序数对
啊？
这个不表示数对的意思。
数对是什么？说英语。 pairs 啊
对
，all the pairs，all the pairs，对呀，对对对对，我们的定义就是说，as long as 这个是一个 subset of A cross A 就好了。这个是不是一个 subset of A cross A？对不对？但是你的 relation 在你的概念里面，你说一定他们之间有一个什么纯关系，那纯关系你一定要跟我讲。但是它的概念不是这样，我不需要告诉你他们具体是什么概念，而具体是什么关系。我只要是符合这个条件，它就是一个 relation，明白吗？不用，
怎么找？
我只要告诉你谁和谁有关系就行。
有这个东西
啊。我不告诉你为什么他们两个有关系，但是我告诉你这两个有关系。
这个符号就表示有一点，就这个符号就表示
这就符合定义哦，因为定义说 relation 是一个 subset
两个的子集。
我的意思是这个叉，这个 cross，cross 它就是表示有句对还是什么？
对，记得吗？这个 Cartesian product， 你记得我们上次讲 define 吗？
不记得。
不记得啊，这样要 recall 一下哦。所以这样的话就不忘记这个 definition。
没有电了，
叉是什么？
没有电了，
没有要问一下那个郑传。
没有啊，
哦，
是软的，我们收了。
这个能给你用吗？
应该是不能。不能，因为它这个是那个，
iPad。
因为你的这个的话，OK， 这样的话要 recall 这个。
这个叉是什么东西？
它是 Cartesian product。
Cartesian product。
Cartesian product 的意思，这个就是它的定义，它是 order pairs。第一，它 order pairs，order pair 里面长怎样？两个东西都要活在第一个和第二个里，一个活在第一个里。所以它就长这样，对不对？Yeah。
我考试是不是考到了？
好的。
midterm 考到了。
有考到，对，有考到。
midterm 成绩什么时候出？
老师改卷了，我要手下留情。
可以。
捞我。
可以。
都是讲
菜捞捞。
可以的，
都是讲科研的，都是可能是一样的。这种叫稳住你。缓兵之计。
先稳一点。
midterm 什么时候出啊？
等我改完了。
没改完。
呀，等那个
你也不希望他这样快出了，相信
怎么样？评价。什么是评价？
评奖有这个
奖评。
所以你会
就应该会啊，应该会。
在家最多明年再看你一次。
我不想看你。
明年我就会啊。
retake 是吧？
我不想 retake。
什么是 retake？ 这个问题很好，其实我故意不讲。就是我要有你一个先决的条件先，因为如果你先决进来，也不会错到哪里去。
刚才突然说 partition 我就。
对。
是可以讲一下。
可以是可以，但是。
没有，老师刚才就是突然讲了，我就
对，我就有些词啊，我故意不要跟你讲的，因为
例如我看不懂，
因为我要你去意会先，比如像那个 relation， 不是我让你去意会啊，他就会想回他的东西，就我不可以让你去意会，因为我要你知道我们现在的 relation 是这个东西，所以我不会让你去意会这个东西先，因为你意会的话，你会有一个更先入为主的那个东西。但是我们不想要那个东西，对不对？但是现在partition我要你去意会一些。其实我还没有 definition。啊？
老师没说。
partition 的意义其实就是
包括它是direct transfer 是什么
？partition 啊
，direct transfer 也不知道。
direct transfer。partition 就是说你把你的东西分。就是分组。对，当你分进 partition 的时候，每一个 partition 的 element 不可以重叠。
老师这样子，
不可以 overlap， 不可以有 overlap 的 element 在你的 partition。
所以说这个其实是一个 partition 啊。
对。所以这里面的东西不可能活在其他地方，不可以 overlap。
就是说我们这边有7个 partition。
对。
所以每个 partition 有它的 equivalent elements。
对。但是不一样的 partition， 它的 element 不可以跑去 就是不可以有一个 element 是活在不同地方，这样就不叫 partition 了，因为那个东西就又不知道活这边，又不是活这边。partition 的话就是不会有重叠。
就是这节可以整个一个理解为一个 partition 了
啊，对呀，对呀，对呀。
但 partition 应该是类似部分化吧。
我不懂，我不懂部分化的那个，
就一个部分一个部分
也可以，就是不可以有重叠，就这样。
这两个
会有
重叠，
来一个，
这两个就是
不可能啊！你试一下，不可能的，你试一下。
是像你刚刚上课举的例子，那什么 class 来着？
对，等一下，你等一下。Hello. Hey, you guys should start with the tutorial question I already posted on the Moodle. Yeah. Huh? Yeah. Yeah. 0。如果改成7，改成6的话，0到0到5。
是可以扣
啊，对。
是这个，是0，就是里面的这个
长得一不一样？不一样啊。OK， 对。
对，但还是
可以写
还是0的这个 class，
也是有0的这个 class。
对，但是里面的元素。
对。
怎么换 x 呢？它的这里面元素会变，它还是所有一坨坨的 class 都是。
你可以叫它0啊，你也可以叫它6啊，你也可以叫它不同名字的。
相同元素。
只要活在这个里面呢，我们都可以把它。
这个带这个号子叫equivalent，
对，戴帽子这样。
所有都是。
Yeah。
这是它的equivalent。
Z。
这个说过什么优点？这个地方比较好写，当时可以。
这个。OK。没有，我的意思是说，这个 partition 的意思，这个其实是一个 partition 的概念，就是每一个也只能活在这个地方是说，如果我看气嘛，气的话，你通常是想从气开始出发嘛，气14啊0啊，但是为什么这个 set 跟这个 set 是一样？
这样的congruent。
好的，对啊，说的。
congruent 默契就是也是一样。
所以每一个活在这里的东西都活在这里，每个活在这里的东西都活在这里。哪个？
为什么会有 relation？
在哪里？
那个
这一题啊
，positive。
这个。
它是问 transitive。
reflexive。你要问谁
reflexive。
谁是 reflexive？你要问谁的 reflexive？
知道为什么 A 和就是自己的和自己
0就等于0默契。
对。
所以就这样子解释是吧
E 就等于 E 默契，那刚好就有关系。
那你要 show for OA 嘛，这样你就 A 减 A 是 A 减 A 是可以被剔除
少一区。
对不对？
之前那个 PNR。
还是要带入历史看嘛？
我有双手。
对。
双脚，他们都是我的。
都是你的吗？
身体的一部分。
你的手，你的翅膀。
我就睡着了。
就 A 的 A。
我说。这之前上面讲的那个 PN 啊，就是排列组合那个中国好像叫 A。
咱叫 A，
我们叫 AN。然后 C 就是 C， 对，这个
我们 A 是
我们叫 AN，
有序，
这个叫 AN 的，
对 ，AN， 2在上面。
为什么这个不统一？
那 P 换成 A。
不大写就是大写 A，
大写 A，
然后 P 要这边是。
可能你们用 arrangement 呢是用 A。
为什么这种东西不统一？
我也不知道。
自然系是 P， 自然系是 P。
有 C 啊，
有 C 是一样，C 是一样。
可能用 arrangement 呢。
不懂。我们是 commutation， 我中学就是这个。所以我们
2是的。
没有啊，马来西亚的没有是吧？宣传部都是 P， 他们哥哥讲他的是 它的 n 在下面，我的 n 也在下面。
图很混乱。
哪个图？
括号这是
去转一下。
哪个？
这种，对。
对。
我写 C 可以，我写 C 它可以分。
哦，OK。
就
老师以后改正会很辛苦，有很多事。
哦，是哈。
对。
对啊，没有，我想我要统一试卷，统一这个。
能不能统一到 C？N 在右边。
对，我们可以用 P，可以用 C，但是它能不能全部放在？
对啊。
只是统一这个了。
我们退一步，
计算机可以按的。我们在右边。
如果你情不自禁真的写那个算了。
这个你要用这个这样子形式按计算机是顺哦，
是不是？
你就直接顺，用 C 看计算机不一样。如果你用这个，
因为我真的差点扣分哦，导致什么？他们没有跟我讲，然后我第二天交这个嘛，然后他们讲哦有这个哦，讲难怪你们这样反着写，那你反着写可以算上这个答案就奇怪，然后就呀算了。
我刚刚那证明没看懂，那个就是
这个
点多点够用。
这个。
你刚刚是有个证，
不是有一个很大、
很长的
黄色的，对，
很长，
是那个得那个
阳黑三角，
这个
阶层，然后阶层可以消的。
这个，
那这个
那个
K 没有 KN 就是阶层，括号里层 N 的阶层都可以分开成。
同层那这怎么换成一个？
它通分了，
它通分了。
它通分了，但是底下分母不一样，还是不一样啊？
一样的呀。
这 K 减1，然后这是 N 减 K， 怎么一样？这个和这个一样，这个和这个不一样，这个和这个一样。
7的乘阶其实是6的乘阶乘7。
哎，它是不是？
这是个加。
这一个和这个一样。然后剩下的增加一样，看到？看一看，盯久一点。
可能要再 detail 一点。
哎，有什么好比？算了，好，可以。
超级 detail。
是男版的左的。
一样，K 减1就是把这个写回来，
它是女版的，女版。
你在讲什么？他把上下展开写的。
其实就是这样。
对，它展开。
你把它打开。
你把这个展开，就去。
它不是 K 减1的阶层，再乘一个 K 就是它。
对。K 的阶层 K 乘 K 减1的阶层。
不好够啊！
这个，
你要不过来，
你
要不过来，你这样。
这个，
不要小字。
这个，看得到吗？
就好了。
看得到吗？看得到吗？
他这边是约分的时候，他从这边到这边。
我没有约，我只是
没有，他减了之后变成他。
为什么？我不理解。
哦，对。
哪个东西不理解？
这个啊，为什么？
但你应该是不知道这是什么东西。
我知道，我K乘1阶层，那K乘以K减1乘以
这个知道吗？
哦，
这个知道吗？这个知道吗？
知道。
啊，又知道了。
知道。
看懂吗？
来一个数字试试看。阶层的情况下，再乘上一个 K， 它就是 K 的阶层。K 的阶层就是 K 乘 K 减1乘 K 减2减。
比如7乘6，
把 K 的这种写出来。
懂。
这个也是这个同理。
这个
神奇。
Similarly 是同理是吧？
这个为什么又同理啊
？Similarly，
因为把 n 减 K 看成一个8K。就是加1，减下去。
我
已经忘记阳黑三角公式。
没背过。
我们直接背公式。
我们直接
阴阳裂开。
经常已经裂开。
非常好。
什么公式？
将每节数学都裂开。
就是几个 x 就分几个，有 c， 比如说 x 个 x 减那个你的那个例子，
地址上的叙述，
就是
PN 上的叙述，
3个 x 一个 y， 就是第4版这样。分别是背公式。
这个公式不是这个吗？这个公式哦。就是这个公式吗？
长得
大概是 CNK。
我高中就没有看过这种。
然后我要减。
不是，
我
这个
中文在
就是看你喜欢
就是
的，
不是会有很
最
多像
多是我这个
S4方，然后还有什么 S34方块，那
对
这个我们就会看成 C4
啊，对啊，一样的，
哦，
一样的。C34跟那个，那你看，这个跟这个
对，
今天的跟这个一样，对，没错。
我跟你说，这公司的口
哦，所以这括号
还有一个是
这可以画成 C 是吧？
是 C2，
不然 C2
这个可以
然后一个是事物之和是
哪一个？
事物之和是2人
哪一个？
对，我好奇他们的方法。
然后他们是反的 ，n 在上面，r 在上面。
对，我们就是这么
他们是 n 在下面，r 在上面。他们是 n 在下面，r 在上面。
怎么会这样？
他是这样。
不是看着好难受。
可是点计算机，
我不用
我们
我们看计算机看这个肯定是这样。如果很大的号码的，
我们考试不考
对，
考很大的，
一切为了考试。
确实。
差不多
我
10
们都是考很大号码，但是答案一定是1、2、3、4、5、6、7。
所以你们可以按计算器，
可以，
我觉得
不会了呀。
高考的安全系直接
因为我们考数目会很大，
有点不好就细微。
多大很大？
我们有很大的，但是有
没有很大，但是我们有一些
那种应用题，
对，它可能有一些技巧，
对，
或者是什么，
运算技巧，
对，还有那个
凑
十字相乘。
哦，10个相似，
我们有时也是会自己
受不了，
我们也是很多其实没有用在他们的算起来
也是用
我们里面也是可以，
我们有背，只是懒惰。
还有那个分
我们有背，该背还是要背。
分10大除法，把一个多项式
哦，
多项式
整数大除法，
对，拆成几个单元，每个反应挺。
那个很少用，那个是
哦，
要看后
我其实是听懂了，只是我觉得我回去要怎么
再读一读，
要一定要，
这是
不然
标准吗？
但是你讲话其实我没有什么不太明白的地方，主要刚才那个你是叫我看清楚那个就是那个紫色，然后那个紫色
现在去，
那你再上去哇 ，N Z K 那个，我讲我看不懂哎。
哦耶，
啊，就那个的办法，这
这个
种我很早就懂，
你很早就懂，
就跟那世界原理一样，
就是那个
就是我就懂了，就是我懂了，
你问他，你要听他讲。
他还在厕所有个悟道的一个世界真好，
然后时间延续到这里是我很懂的。
哎，那讲话莫德还是在山洞里面。
真的在苹果树下，
那个不是讲。
哦，这个 A 上面有个帽子，不是 inverse 啊，之前 inverse 也在。
对，
对，老师 prefer
是 A 把
A 把，对，
什么1把
这叫
A 把
？A 把
平均数也长这
A 把平均数也长
呀，对，inverse 有时候会这个，有时候放那个减一。
哦，
好多表达哦，
对，
数学的世界
就是数学啊，
就是看你在什么地方，
怎么还看场合？
看场合的，你当然是要看场合说话了。
数学永远都是对的。
数学只有对和错，
我还讲上
你也信给我道理，数学只是
老师他们那本书前面那几章，
他这样
也讲怎么走，前面不是直接跳到地
啊，跳了，我们跟着跳了。
对，这一块很后面
啊，
这一块很后面，
后面吗？
看一下那个书大概600多页。
为什么？给我看一下。
这样，
为什么这样？
我是英文版大概600多页。
我是英文版。
这样，
不是中文版那个排版，这门课
他为什么排在那边？那个是什么？
是离散数学其实就用第2个。
哦，应用。
对，离散
是给他那个课本这个章节很后面。
很后面。
超后面
给我。们那个天什么那个。
啊，第9课，第九课，
因为不是每个都教，因为不是每个都教。我们学的是 Discrete B，
我之前
不是数学题，数学系要学哦。
我这个
什么？
我们只是学部分，我们只有学7个，
还好。
其中7个单元。
0的教授。
0啊。
然后我们之后好像就没有数学了。
很好。
美方
好像我们好像就剩下那种。
教授。
对啊。
你知道我们老师叫什么名字吗？
我不知道，我连姓我都看不出来。
你也姓
哦。
人字
泥筐，
你是人字旁，繁体字的
怎么还会有你？
泥瓶的泥。
哦，这名字叫什么呢？还是看不懂。
你给
它是方言啊，你们南方的方言之一，像我们自己华人的名字都是之。
我也会闽南话，还是听不出
你
来。
会闽南话？
你是福州是吗？
闽南人
你是福州？
我是，
因为他是福州。
爸爸是泉州人，福州人，我妈是福州人。
你妈是福州人？
可是还是不会闽南话。
很少见的。
很少见。
你记性，
我有朋友
也
是，
他就是方言
福州话。哎，我听福州话就是天书英语一样，听不懂。
我们自己的姓黄也可能是叫安汪。
那个咱们 CF 那门老师叫考这个方式叫 Q，
那就是方言翻译过去。C 加加老师，好像你们
怎么都是华人哦，谁幸福死了？
他们华语一样，然后应该
C加加那个
C加加那个老师没多语种，
听说会日语。
这个是不会了解，
老师
他是日本留学吧
？C 加加老师
东大的。
C 加加老师怎么讲？他就天天就给我们放网课，让我们自己学，然后期末考试出那个题就是那个竞赛题。我写的都要哭了。我一个同学说我做过原题，我说你什么时候做？他说之前高中考竞赛的时候做过。我们管它叫 KS 卡木兰。
我也是试下来是的。
他好可怕，我很怕。我们去年还有一门课给他教了下。
那你是专业？
没有，我是 retake。retake。
好，那你大二的时候？
对，我现在打。
你是软工还是数媒？
数媒，跟人课一样差不多。这是什么？是。
你可以送。
我之前一直以为我的姓汉，结果他跟我说他姓郑。
对，
D A Y。
D A Y 对，
郑。我是姓郑，对。
对。
陈也有很多姓，陈姓蛋也姓陈，还有陈姓。
然后你们名字都很拼，所以我就管他叫他名字。我跟你面试。
就像张姓，没有张错，写错张，
还有我找这个是连接，
通常是中国人才会用这样。
丢也。
丢也是，
对，很多。
丢很姓张。
听起来就很方便。
这有这就是。
然后英文的那
个，怎么这样
？Let's go。我吃饭了，我们大家有课哎。然后有人要抢你的课，本来有人他想抢我们贴合，还要抢你的课，他抢了。
有时候就讲，因为我们跟天老师讲有这个时间定好，
然后我们就帮你讲啊，我讲你很早就定好，他就哎呀，他为了你，他现在已经骗到12月了。
你们几个课要补哦？
因为斯兰诺苏丹放假，不是生日，有很多拜一。
我现在好像我会欠吗？
你退什么？哦，
我很多，我周四还要12点还有
就25号，就25号，25号，反正已经定了，我放在那个 notice 了。
其实很多课要补，因为我们这个斯兰诺州，
我也知道，
斯兰诺州是撞到星期一放假，12月26号放假嘛，那个圣诞节。
圣诞节也放假。
这一过圣诞节。
11月26号是圣诞节
，11月25号是圣诞节在星期日，
我假
在星期日。OK， 圣诞节，
我假，
圣诞节，
然后斯兰诺的那个苏丹好像也是在
不知道几时，
也是
说哪一个半夜，反正每次都是半
夜。
什么？
是每个苏丹节日都要放假。
就不，那个州放假，
就是很像这个现在是北兰尔州的苏丹，就是他这个州的王放假，所以这个州放假而已。你去其他州是国家是照常。
不同的假。
像我的州就从来没有放假，因为我州没有王。
有亚利伯多。
亚利伯多我们不会庆祝的。
你们没有咩？
没有，
管他啊！因为我的州就是没有王。
是什么州？
我是沙巴。
他没有州，但是他有元首。哎，我感觉你们读的感觉现在比我们读的更
那我们不是一样啊？
是啦，我感觉
中国人会读的更仔细。
我讲马来西亚那些应该都没有什么仔细读，我们在读那种系列的时候。
读历史还读宪法，
很容易啊。对啦，可能我之前是历史，
应该啦。
我是拿历史的中学的时候，我就觉得很容易，看就好像发呆，你知道吗？
你们学什么？
好像背过很多次啊。
是吗？
就是那个宪法。
宪法就是讲一些东西，然后就是给你列那个宪法一条一条。基本法，还有什么人身自由，还有什么，
尤其是讲大选那种哈，
也讲蛮
人，哎，你不要问哎，
有去年学的那个历史，
那本讲
不是无人反对，
对的吗？
有人反对。
我还记得马来西亚历史呢，去年学的，哇，那考试考死我。
马来西亚
什么课是学马来西亚历史？
下学期会学。就是会学殖民的历史，然后什么选举委员会，
现在就来了，不知道从
马上就要选举了。
哦，你们学历史？没想我上学
那个历史讲了2章节，我整个人脑袋都大。你们的教育也有。
我们的什么？
我们教育就要分学校，你就很
对，
华人有个学校，马来人有个学校。
他是读中哦，
我是读中。
很多大华都是读中，我的朋友也是读中。
读中是吗？
独立中学，他们是
不是国家？
对，
民办
不是政府，
他们考试
理解为民办。这个民办跟那边最大不同点是，我们这民办这边政府不会要我们学华语，不支持我们学华语，所以他不会给予这种有教华语的学校资金，所以就变成民办，全部都是我们自己抽的。
但是国民性也是有教华语，
对啊，
国民性小价如果
他们学校就是好像他们学校是考4门和数学、法语、英语和华文不能考。反正我那个朋友就跟我讲，
这个只是在讲跟不同之间还有不同。很幸运。
然后就是柔佛那边的新山，是新山吧？就后八路。对。
有人在我
他们那边就英文比较差一点。
不是国中，初中跟国中在我们那边拿分数。
好吧，他
读中
我
考一
啊，是，
我那学
我每次我看那个分野，我就不下滑。
有的
OK，
反正
没有错，
我觉得国中就是不喜欢学习，就大概。
国中是政府，
我们那里是，因为我们那边国中的老师比较
不是，
可是
不是
而且夜班，
就他们就是
暴力。
是哦。
考2场试，一个是政府组织的，还有一个是干嘛？
我有几个国中
中学考，
就是很重要，
就像我们高考过2场，然后有些人第1场就玩一玩过去了，主要考掉。
每周不一样。
真奇，他们
这些有会考的。
可是我真的讲，真的要读书，在国中他也会读。然后你在或者那天才都知道。大家有一点是国中的，
升高考全国1。
你是读中？
我是国中。
羡慕你们那年数学。
什么？
我说羡慕你们那年数学。
可不多考20条。
老师，你什么时候能问你？
我河北的。
那个8月。
我们是全部上海，你是上海的，上海 S， 上海 S。我必须按照我讲就是。
OK，
就是
OK。
你们是科
Foundation， 没有读 Foundation 吗？
不是直接读中高3进来。
他们读 Foundation 只要绩点保持在3.5以上，然后就可以免学费。
你们现在怎么？你们是要又是考这个？
我是 Foundation。
又问下。
我那个朋友是拿了70%的折扣。
这边当地。
所以马来西亚政府要举办2个考试，因为读中太无敌了。他的读中的教育体系有点像我们国内的应试教育，但是没有那么强，但是还是很像。你想象一下，然后在这样的大环境底下。我们那边再好的中学都拿不到10个名额。
因为河北省清华文科只招1个人。
对，我们那边1中就5个都能拿去宣传。
上海交通，
这什么？
金港人哦，西安交通。
高贵的杨大人。 高贵的杨娜。
Yeah, we don't have much time now. Yeah, so I put out the solution here. Any question you want to go through last before we dismiss? No?
你懂我看着，你懂我看着，
OK 啊，看其他人的吗
也会看着。
？OK 啊，Yeah。Okay. Yeah, I'll pull out the solution later. And then anything you can ask next week or come to my office hour or actually you got helps on Maths Help Center, right? You know, can go to the Maths department and ask the master student every day 2 to 4 p.m. Every day or Monday to Friday or 2 to 4. Yeah, Maths department. Huh? Not me, the master student. Yeah. Yeah, my office hour is Tuesday. 12 to 4. Yeah, 2 to 4. We have Maths Help Center. Office hour. Yeah. Course info, you look at the course info. Course info.
OK. Thank you. 啊 Thank you. Thank you 你啊。
这些东西。
OK OK。校长记住，你看什么意思？
讲
刚刚 recording
还会在，好不好？
没 recording。不见大家紧急啊哦。
然后 note 等下不见了，要我们就没有读了。